Okay. Wow, this one's a long problem. All right, so this will probably be the last one for tonight. This one looks pretty long, but it also has some cool, uh, thoughtful aspects to it. So, all right, so let's look at this. So, 2 Tech 45. It says, well, let me blow up the whole thing so it's a little easier to see. So, while waiting for a bus after school, Renee programmed her MP3 player to randomly play 2 songs from her playlist at the right. So here is her playlist. She's got I Love My Mama, country song, another country song, R&B, rock, and rock. Okay. She's got a lot of songs with the name Mama. I Love My Mama, Don't Call Me Mama, Carefree and Blue, Go Back to Mama, and Smashing Lollipops. Girl has some weird song choices. Okay, so, alright. So, let's see. She programmed her MP3 player to randomly play 2 songs from her playlist at the right. Assume that the MP3 player will not play the same song twice. Okay. A sample space, ooh, this is cool. A sample space is a list of all possible outcomes for a probabilistic situation. List the sample space for all the combinations of 2 songs that Renee could select. The order in which she hears the songs does not matter for your list. How can you be sure that you listed all the song combinations? Okay, so sample space is a list of all possible combinations or all possible outcomes. So we've talked about this before when we talked about drawing a card from a deck of cards. If the deck of cards has 52 cards in it, what is the sample space if you draw 1 card? Well, it's 52 because all 52 cards are different. So you can have any of 52 possible outcomes. So we want to find the possible outcomes for all combinations of 2 songs. But the order doesn't matter. So if we have song A and B and A, that's the same combination because the order doesn't matter. Okay, so how can you be sure that you listed all the song combinations? Well, we just have to be systematic with how we do it. So one way to do it, and the way that I'll probably suggest that we do it here, is we do it alphabetically. So we're going to say A and all the other songs, B and all the other songs, C and all the other songs, D and all the other songs, and then E and all the other songs. So let's go ahead and start listing those out. So I'll just say, let's say that the first combination is song A and B. I don't know why it capitalized it on me. So A and B is 1 song combination. So what's another song combination? Well, A and C. I don't know why it keeps capitalizing that. A and C is a combination. A and D is a combination. Why does it keep doing that? And then A and E is a combination. So A and B, A and C, A and D, A and E. So, all right. So there's those 4 combinations. Well, now, what about the combinations with B? So let's move over a little bit. And let's do the combinations with B. Well, what could we have? We could have B and A. Oh, wait a minute. Since we're going to list them alphabetically, we don't need to worry about B and A because we already covered that one. All right. What about, we can't do B and B, right? Because it says here, assume the MP3 player will not play the same song twice. All right. So we don't need to worry about B and B. So what do we have left? Well, we have B and C. And then we have B and D. We have B and E. Okay, so does that cover all the combinations for B? Well, yeah, because can't have B and A again. All right, so that's all of the B ones. So let's look at the C ones. So what could we have? C and A? Oh, nope, we already covered that because we have C and A already. C and B? Nope, we already covered that one. So now we just have C and D. And then we have C and E. Okay. Well, that was pretty straightforward. All right, what are the next ones? Well, we've got D, and can we put D with anything else? Just E, right? Well, that's kind of an interesting pattern. Look at that. So there's 4, 3, 2, 1. Did we miss any? I don't think so. We got all the ones where A is going to be in there. We got all the ones where B is going to be in there. All the ones where C is going to be in there. And all the ones with D is going to be in there. Well, that's pretty cool. So how many were there total? There were 5. And so we chose 2 of them, and we ended up with 4, 3, 2, 1. So 4 plus 3 is 7, plus 3 more is 10. 10 different combinations. Well, that's kind of cool, huh? All right. So, how can you be sure that you listed all the song combinations? Well, if you did it systematically, then we can be pretty sure. Start with A, write out each possible pair starting with this letter, then write out each new combination with B. Keep in mind there should be 10 pairs total. Answer, 10 combinations. Perfect. Just what we did. Good to know. All right. So, are each of the combinations of 2 songs equally likely? Why is that important? I would think they would be equally likely. Let's see. Randomly play 2 songs from our playlist. At right, assume the MP3 player will not play the same song twice. Yeah, it looks like it'll be... Are each of the combinations of 2 songs equally likely? Well, yeah, because it doesn't say that there's any preference for any of the songs, so it seems like they'd be equally likely. Let's see what they say. See the math notes box in lesson 2.1.4. Yeah, that doesn't really help me. Great. All right. I think they're equally likely. Okay. So then the question is, calculate the probability that Renee will listen to 2 songs with the name Mama in the title. Man, which songs have Mama in the title? Okay, so A, B, and D. So that we'll listen to 2 songs with the name Mama in the title. Okay, I gotta write this down. Or actually, I'll just do it here. Okay, so A, B, and D. So if it has, I guess let's see. So if I can highlight maybe the ones that have A, let's see, how do I highlight? Highlight, 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 highlight. There we go. Blue. Okay. So I'm going to highlight all the A's. Highlight. Highlight. Okay, so that's all the A's, and then because they have Mama in the title. And then B's, so highlight all the B's, because they have Mama in the title. Whoops. Ah. Highlight, I say. Highlight all the B's, because the B's have Mama in the title. Okay. And then, is that all the B's? Yep, that's all the B's. And then the D's. D's have Mama in the title. So this one has Mama in the title. And this one has Mama in the title. And this one has Mama in the title. And this one has Mama in the title. Okay, so that's all the songs, A, B, and D, A, B, and D, that have Mama in the title. Okay, so now what's the question? Calculate the probability that Renee will listen to 2 songs with the name Mama in the title. Okay, so let's look for the pairs that are both highlighted. Well, that's 1, 2, 3 pairs that are both highlighted. So what is the overall probability? 3 out of 10. Whoops, 3 out of 10. 3/10. Let's see if I can. 3. Well, you get what I'm saying. 3/10. All right. So what is that in decimal? That's 0.3. So 30%. Is that right? Yeah. So the way you could calculate to see what percentage that is you're going to make sure the bottom part is 100. So let's say, let me make this a little bit easier to see. So let's do insert, equation. Let's do 3/10. So how do we find out what percentage that is? Well, we want to make this 100, so I'm going to multiply the bottom by 10, multiply the top by 10, and there we go. That equals 30%. Okay? So, the probability that Renee will listen to 2 songs with the name Mama in the title is 30%. Let's see if we got that right. Find all combinations with the word Mama. 3/10. Got it. Boom. All right. What is the probability that at least one of the songs will have the name Mama in the title? Ooh, okay. So let's do at least one of the songs. So let's put that back to something here. So at least one. So that one has, so this pair has 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, only this one. So 9/10. 9/10 or 90% equals, whoops, 90%. Okay. At least one of the songs will have the name Mama in the title. Boom, 90%. If one element of the combination contains the word mama, then it applies to the question above. 9/10. That's a lot. Why does it make sense that the probability in part D is higher than the probability in part C? Well, because you're only requiring one of these songs. You're only limiting one of them. Whereas the first one, C, limits two of them. You got to have both of these have to have a certain condition, versus just one of them has to, either this one or that one. That's kind of an easy question. Why does it make sense? Well, okay. Wow. Well, hopefully, actually, that wasn't as difficult as I thought it was. It was just kind of long. But that's basically how probability works. So once you know that sample space, that's basically your denominator in the probability, and then it's just a matter of counting the options that go in the numerator. So yeah, actually that wasn't that bad. Okay, cool. Well, it was still pretty long though, so let's go ahead and call that one the end. So all right, well thanks for listening, and I hope it was helpful, and I will see or talk with you guys again soon. All right, bye bye.